So now we are ready to start to reap the benefits of capturing the metadata in formats that are a bit more machine friendly. And this is one of the most important aspects of turning knowledge into metadata, is essentially taking these text files or PowerPoints or Excel files or sometimes things that exist in data manager head and turn them into a format that can be understood by computer systems or software. So there are standards that exist to do that, and we all work aligned on a few of these standards. These include the Data Documentation Initiative or the Statistical Data and Metadata Exchange standards. But these are XML or JSON standards that are not particularly easy to use for everybody. So we came up with Metasheet as a very simplified version of these standards or different models because we wanted to have a tool that everybody can use. And Metasheet is far from perfect. It's far from ideal, but everybody knows how to use Excel or to use Google Sheet. So once we have this in this format, we've developed also a little Python utility around this that allows us to read the sheets and start generating things from it. Such as scripts and standards and other things. So we got to do that now. And what I've done in my workspace here, where I've been working on these files, I create a little Metasheet folder. So I'm going to go to my Google Sheet and download it in Microsoft Excel format. And let's see, it takes a little while for Google to prepare the export. And this is going to be saved into this Metasheet directory. So it's going to download it. So if I go back to my file system, I now have this CMS underscore Metasheet file. Now I'm going to open a terminal, command shell. And I'm in the Metasheet directory. And from here, I'm simply going to run this command, which basically says, hey, I'm going to call Python. You're going to go and grab the Metasheet Python utility. You're going to apply it to this CMS Metasheet. And there's an option that I don't need there at this point. It is load. And I'm going to ask this to generate SQL scripts for Postgres. I was doing a little testing before. And also, I want to generate DDI XML in version 2.5. So I'm going to run this, and what this Python script will do, it will read the sheet, parse it, turn it into an internal metadata model, make sure it's all correct. It's going to do some little inheritance to reuse the variables and codes and teach everything together, and then generate the scripts I've just asked. There are other things we can do. We can generate other scripts than SQL and DDI. You can generate for other database platforms. We could also generate, for example, code for SAS, data, SPSS, and other things. But if I go back to my directory here, I see that I have two new files. I have for each of the record layout, for each of the tables we have in there. One for the CLIA file, one for the other file. And I'm simply at this point interested mainly into the SQL. So if I open this Postgres.SQL, what we have produced here is simply a little create table statement that has all the variables and the variable. The point is, I mean, this data set is not too large. Maybe this one has about 100 something variables, but you never want to retab this. And once you have the metadata in machine actionable formats, there's a lot of things you can do with it, in particular generating code for you, or generating documentation for you, or generating a lot of various outputs, which are in the end simply different representation of your codebook or the knowledge around the data. Now, what I can do with this, I can connect to my Postgres server, run this code, and then my table will be created in Postgres. And after that, I will just need to move the CSV file and load it on the server. And we have this for both of the data tables or data files we have here. So this is the other file. The other thing we have in there, and this is going to likely look a little bit more cryptic for you, it's a DDI file. And a DDI file is really kind of think of it as a codebook translating into a machine-friendly language, which is called XML. You might also be familiar with JSON, which is another friendly language typically used for metadata. actually quite popular nowadays. XML was more popular in the past, but still very widely used. So if I go here, I'm going to go back to my screen here. This is what the XML looks like. It looks even more cryptic when it's not organized in a human-friendly fashion. But now you can start to read this, and it's not very complicated. You're going to see that essentially it is your codebook in an XML language. What you find here is, for example, this provider category code variable. You're going to tell you which file it belongs to, the name of the variable, and at this point you're going to find all the codes in here. The advantage of this is a standard format. It's not only used by our system, but it's used by many organizations worldwide. There's a standard called Data Documentation Initiative. You can find on ddialliance.org website. So this essentially can be understood now by everybody understands the standard. And we do use this in our system to populate metadata around the data product. So when we load this data set, after it's going to be loaded in the database, we're going to publish into a rich data services platform. And once it's registered, we're going to load this DDI file, which is going to populate the metadata with the data. And at that point, we'll be able to deliver both concurrently. So just know at this point that this XML file is essentially a machine-friendly standard representation of the layout file or the codebook. But by turning this into machine-friendly format, then we can start automating and do a lot of things. So, and this is one of the benefits of Metasheet. Metasheet as a spreadsheet plus the little Python code, you can start generating a lot of things like this. So next step will be to take this, push the data into the SQL database server, which we will dive into shortly.